Hello everyone, welcome back to the Blue Team training series brought to you by Hackersploit and Linode. In this video we'll be taking a look at how to perform network intrusion detection with Suricata. Before we get started, I would just like to thank our sponsor for this video and this series, and that of course is Linode. So thank you to them. They make series like this possible. If you want to register for part 2 of this series, you can do so by clicking the registration link in the description section. As I said, in this video, we're covering the process of performing intrusion detection with Suricata, or using Suricata to essentially detect intrusions and attacks on your network. So as I said, Suricata and Snort are very similar and can both be used for intrusion detection as well as intrusion prevention. However, in this series, because this is an introductory guide to Blue Team operations, we're not going to be taking a look at intrusion prevention in regards to an intrusion detection system, or we're not going to be exploring it right now, as you already know. And of course, we already explored a little bit of incident response and actively reacting to threats in the previous video, but again, we're primarily focused on detecting malicious traffic or traffic that looks suspicious on a network. All right, so in terms of what we'll be covering, we'll get started with an introduction to Suricata. We'll then take a look at how to install and configure Suricata, the Suricata rules, how to update the rule set, as well as the Suricata configuration file, how to write custom Suricata rules, and how to perform network intrusion detection with Suricata. So the objective here is to introduce you to Suricata, show you how to set it up. It's much easier to set up than something like Snort, for example. The actual one really cool thing that I like is the fact that the actual configuration file and the Suricata syntax is almost the same as Snort. And that is really awesome because it means you really don't need to learn anything additional. The only thing you need to know is how to run Suricata and where the log files are stored. But in terms of the rules themselves and the rule syntax, it's pretty much the same. There's just a few minor differences between the two. Now, you might be asking yourself, well, if I'm running Snort, why would I want to switch to Suricata? Well, Suricata is pretty much my go-to solution when it comes to an intrusion detection system, primarily because it's much faster and much easier to manage. And this is not saying that Snort is bad at all. I just prefer Suricata, and that's why I wanted to cover it, right? Now, at the end of the video, as a bonus, I'll be showing you how you can configure Wazuh to actually read the logs that are produced by Suricata. So if you install the Wazuh agent on a Suricata or on the server that's running Suricata, then you can essentially read or import those logs into Wazuh and also get information regarding the threats or the suspicious network activity going on that network. So you're actually learning more about the network and what's going on, and you're not really focused on individual agents or individual systems, which can improve your knowledge as to the actual threat surface, help you identify threats much better or much easier, etc., etc. So the prerequisites, you should be familiar with them by now. They're essentially the same as they have been throughout the series, with the exception of the Wireshark video. Right, so let's get an introduction to Suricata. Suricata is a free and open source threat detection engine. It does this by combining intrusion detection and intrusion prevention functionality, as well as network security monitoring. So Suricata is owned and developed by the community-run non-profit organization called OSIF, also known as the Open Information Security Foundation. And you can actually find the Suricata GitHub repository linked on this slide. The Suricata website is also hyperlinked to the Suricata word at the top there. So if you access these slides, you'll be able to get the links. And of course, all relevant links will be added to the description section of this video. Now, Suricata has two main operational modes, right? So it has an active mode and a passive mode. And as you can tell, this is very similar to what we had with Snort, with a few differences. The one thing that I like about Suricata is that it's a very well-developed tool. in that it, in terms of the functionality, it breaks it down into two modes where you can detect intrusions and you can prevent them, right? So it's very, very simple. So active mode, as you know, is for the intrusion prevention system, and this is used to alert, log, and block network traffic that matches specific rules. So the key thing here, because this is this is in active mode, this is where you can essentially drop packets, or you can essentially block network traffic or activity that is malicious. And of course, that is done because Suricata matches the traffic against specific rules. This can either be the rule set that Suricata comes with by default, or it can be predefined rules or rules that you have created yourself. You then have the passive mode, which is used for intrusion detection. That's what we're going to be using or running Suricata in. This is used to identify, alert, and log suspicious network traffic within a network. So the objective here, as it was with Snort, is to set up a server or a system on a network and install Suricata on it, and essentially identify and log any suspicious traffic or network activity in order to detect threats, or it can essentially aid your the actual security events and give you a holistic view of what's going on a network, because attackers or threats may be performing tests or maybe running scans on the network, trying to probe for devices. And this is, again, very, very important for a security engineer. You have to take in the actual security of the devices or the hosts running on a network, but you also need to take into consideration the network security aspect of it. How does Suricata work? So Suricata can be deployed as an IDS on a network to monitor network traffic, or as an IPS in inline mode to detect and stop malicious network traffic. So the way it works is exactly the same as the way Snort works, whereby for intrusion detection, all you need to do is just specify the interface that you want to monitor, that you want to run Suricata on, or that you want Suricata to monitor. So you can specify the network subnet and then the interface name, right? And if you are running it in IPS mode, then you're running it in inline mode, which means you need to have this before the switch. So the internet comes in from the router, and then that goes into one network interface, and the other network interface card is what goes into the actual switch. And that means that at this choke point, all the traffic coming in and out is going through the server that's running Suricata in the IPS mode or in inline mode. That should make sense by this point. So Suricata utilizes a set of predefined rules or rule sets to identify malicious network activity. When malicious network traffic is detected and is matched against a rule or set of rules, an alert will be generated and the traffic will be logged. So similar to Snort, these logs can then be imported or relayed into a SIEM like Splunk. Splunk is not really a SIEM because it's essentially used for logging, but we can also import them into Wazuh or configure Wazuh to actually monitor those logs for security event monitoring. Similarly to the Snort video, Suricata can be placed in, it can be implemented in two ways. So in the IPS mode, you can see that the connection, we have the internet, it goes through the router, and then it goes to the server running Suricata, and then it goes to the switch. And if it's running in IDS mode, which is what we're doing, then you have the internet connection coming into the router. You may have a firewall, you may not. It goes into the switch, and then this is where you connect the server running Suricata, and of course it's going to be running in the intrusion detection mode. As for our lab environment, it's essentially going to be the same as we had with Snort. The only difference is we're going to have Suricata running on this server instead of Snort, and it's running on Ubuntu 20.04. I recommend following along with this series with Ubuntu, primarily because it's much easier to use a Debian-based Linux distribution, for the simple fact that package management is very easy, and, products like Suricata have packages and repositories built, for Debian-based distributions first, and then, of course, you have Fedora, CentOS, and Arch-based Linux distributions. We're also going to have a vulnerable Linux server. This is not required because, as I said, we've already explored this with Snort. The main thing we're going to be taking a look at is setting up the infrastructure and making sure that everything is running correctly. So let's get started with the practical demo. I'm just going to switch over to my Ubuntu virtual machine, and we can actually get started with the practical demonstration. So we'll get started with installing and configuring Suricata, and then we'll take it from there. All right, so I'm back on the Ubuntu VM, and again, it isn't running anything on it. So to get started, I would recommend going to the Suricata website, which is at or on suricata.io. If you click on this little this little menu here to your right, this is a collapsible menu. You can click on documentation, and under documentation, you can click on the installation guide. So you can go through the installation manually and compile it from source. And I do recommend taking a look at the Suricata documentation because it really is fantastic. So the great thing with Suricata is you have the binary packages for the latest version, and you'll need to add the repository firstly. So this is the official OISF repository, and it's essentially used for Suricata. So once you add it, you can then update your repositories and then install Suricata directly. So let's do that. So I'm just going to copy that command there, and I'll clear up my terminal, paste that in here, and there we go. So that'll get Suricata, the actual repository, added. So I'll hit enter to continue, and it's then going to add it, and we can then update our repositories and install Suricata. So we'll give this a couple of seconds. There we are. So I'll say sudo apt get update and sudo apt get install Suricata. And I'll use the Y option here just so that it installs directly. So by default, you'll not be prompted to enter the interface. So in that regard, Suricata is much easier to configure and much easier to understand. So this will complete installing Suricata. And there we are. So that's done. Now, one thing to note is that the Suricata can be started and stopped with systemd or the init system that you're using on your distribution. And if you do want to run Suricata on system startup, then you can enable the service. But do note that if you are running this in a virtualized environment and you do not need that functionality, or you don't want Suricata consuming resources and working in the background, then do not enable the service. In my case, I can just do that. So I can say sudo system ctl because I'm running systemd, or this version of Ubuntu comes with systemd. So sudo system ctl enable, and then we can say suricata .service. Don't worry if it gives you this error here. So suricata.service, hit enter. And you can see it's not a native service, so it'll redirect it to systemd sysv install. So it's going to execute it. So that means it's going to be running on startup. So I can then say sudo systemctl status suricata, and it is active and loaded. So we want to stop this. So I'm just going to use the previous command because we don't need it running when we're making configurations. All right, so now that that is done, let's take a look at where all the configuration files and rules are stored. So as I said, it's very similar to Snort in that if I list out the contents of the etc suricata directory, you can see that you have the suricata configuration file that's in a YAML, format, which is great. I really like configuration files that are in YAML. And then you have the rules directory where you have a set of rules that come pre-packaged with Suricata. So for example, if I list out rules here, you can see that we have all of these, these various types of rules based on protocols. So we have HTTP, IPsec or IPsec, if you will, NFS, NTP, SMB events, etc. So in order to modify it, you need a root or sudo privileges. So I'm going to say sudo etc in order to modify the configuration file. I'm going to say sudo etc suricata, suricata.yaml. Now, there's a few things that we need to configure. So this file is quite large and there's tons of configurations you can make. But as you can see, it really is awesome because, you can essentially specify or customize the various variables, and it's extremely similar to Snort or the Snort configuration file. So again, the comments to essentially disable a particular option, you can use the hash or the pound symbol. So again, it's fairly simple. So the first thing we need to do is configure the variable. So more specific is better for alert accuracy and performance. So we need to specify our home net subnet address or the actual network subnet that we would like to monitor. So again, you can get this info by saying ifconfig. So I'll say ifconfig. And my interface here is ENP0S3. That's the interface I want to monitor, and the subnet is 192.168.2.0/24. If I type in IPAS, that'll give you the entire network's your entire network subnet range. In my case, it's 24, right? Okay, so we can specify that here. So again, as it says, make sure it is specific. So I'll just enter insert here, and we only want to enter that network. So 0.0/24. All right, you can also specify the other variable options here to add additional subnets or addresses. And then you can specify, the actual external net variable here. So in this case, we can specify, it's saying not home net, so any address that's not in the home net. So that's perfectly fine. And let me just write the changes. So that's the first option that we need to configure. The next option that I would recommend configuring is the actual AF packet option. So I'll just search for it using / within Vim. If you're using a visual text editor like gedit, that's perfectly fine. Just make sure you open it up, or you open the file with sudo root privileges. So I'll say AF packet. And right, so this is the Linux high-speed capture support. Make sure you specify the correct interface, based on the network you're monitoring. In my case, it's ENP0S3, I believe. Let me just verify that. This is very important. So it's ENP0S3, that is correct. And yeah, so that's set up now. If you do want to add another network interface, you can add that on top here, and you can follow this the actual syntax. Just make sure to change the cluster ID and make it unique, because this is very important. Okay, so that that is done. So this is a cross-platform libpcap capture support. You can also configure that interface if you want to. I recommend doing that. So we can actually set it here. Cross-platform libpcap capture support. We can say ENP0S3. I believe that is the correct syntax. Let's just confirm that. ENP0S3. These interface names on Ubuntu are quite difficult to remember. There we are. So that's done. Okay, so I'll write the changes. The next option we need to set, and this is optional, this is the community flow ID option. This is used for event correlation and is useful when using tools like Zeek, or when you're trying to import the logs in JSON format. So this is very important actually. So we want to search for community ID. So community-ID. So we're looking for this option here. Is this the option? Yes, that's the community flow ID section. So this will add a community ID field to the Eve records. These are meant to give records a predictable flow ID that can be used to match records to the to output of other tools such as Zeek. So it takes a seed that needs to be the same across sensors and tools to make them to make the ID less predictable. So you can enable the community ID feature. By default, Suricata already saves or generates a log file and saves the logs in JSON format. So we can set this to true. And I think that's the only options we need to configure right now. As I said, you can go through the configuration file. It is quite extensive. One other option that I would like to go over is the actual rules. Here. So if I search for this rule path, I believe. Is it the rule path? There we are. Okay, so the rule path, this is the default rule path. It's not under the etc directory. You can change it to be there. But Suricata already has a suricata.rules file that is stored under var lib suricata rules. So if you want to add a custom rules file, then you'd essentially, you can specify it here if it already exists within the directory. So if it's under var lib suricata rules, then you can say, you can just provide the name. So I can say local.rules. However, if it's stored in another directory like etc suricata under rules, and then you can say local.rules, then, you can load it like that. So any custom rule or rule sets that you'd like to load up can be done this way. For now, we don't have that file because Suricata does not create it by default. So I'll just write and quit because we don't want to modify that right now. So let's take a look at the rules stored within var lib, and this will require root privileges. So I'll say sudo lsal var lib suricata. Let me make sure I type that in correctly. var lib, that should be under var lib suricata. It's not displaying, so suricata and then rules. It doesn't look like that exists. That's very interesting, because I think, I think we need to run suricata one time in order for that to be reflected, or in order for that to be created. So because we haven't updated the suricata rule sets, we need to do that next. Now, this can easily be done by typing in sudo suricata and then suricata update. So suricata doesn't have a man page or man pages, as you can see here. So you can open up the help menu by saying suricata help, right? And the options, as you can see, are fairly simple. So you can specify the configuration file, whether you want to test the configuration file. And then, of course, you have the suricata update option, which is what we're going to do now. So we'll say sudo suricata update. So let's hit enter. That's going to, as you can see, it's going to use the following directory. So using the configuration etc suricata suricata.yaml. By the way, you can create another configuration file, but I don't recommend doing that. So you can see it's going to load the distribution rule file from etc suricata rules smt. So from that directory there. So it's then, once that is done, it is then going to perform the suricata configuration test to make sure that there's nothing wrong in terms of the options and syntax that you've used within the suricata configuration file. So we'll give this a couple of seconds. It doesn't take too long. All right, so that is done. So now if we try and list that directory, you can see it exists. So you have suricata.rules. And, that contains an aggregation of all the rules. So if you take a look at what was displayed here, you can see that no sources have been configured. I'll explain that in a second. So it's going to fetch the latest rules from emergingthreats.net. So these are suricata rules. These are emerging rules. So that's great. It's then going to load the distribution file there. And it's going to ignore that file there. So that is done. Enabled 131 rules for flow bit dependencies, creating the directory, backing up the current rules, and it's then going to write the rules to suricata.rules. So it's going to add all the rules from these rule files here, or these rule sets, into suricata.rules, which is really, really cool. Now, one of the really cool features that Suricata offers is the ability to specify your own sources. So by default, Suricata allows you to select other sources that you'd like to essentially retrieve rules from, or rule sets from. You can obtain this by saying sudo suricata update. So sudo suricata update, and you can then say list sources and hit enter. So it's going to download the index of sources. So these are all the sources that will give you various types of rule sets based on your own requirements. So the one that we were using was, I believe, let's see, where was this one from? Let's see if it was actually added, or it's using the default one. Yeah, so the default one is not here because it's already added. So these are the other ones available. So we have one from ET Open, that's from Proofpoint, and then we have, and of course, some of these will require a subscription. So you can see the license is commercial in this case. If it is MIT or open source, then you can essentially pull them without any issues, or without having or registering for a subscription. So if we take a look at some ones that we can use, like this one here, or maybe this WinMalware rule set here, in order to add it or enable that source, we can say sudo suricata update list sources, or in this case, we're saying enable source, and then we specify the name of the source. So, we can just copy that there, like so, and paste that in there and hit enter. And you can see that that is done. So now we can update, we can say sudo suricata update, just to make sure that we get the latest here. All right, fantastic. So that is done. So it's now going to test the configuration. And we'll give this a couple of seconds. Once that is done, we can actually test it ourselves, and I'll show you how to do that. The syntax is very, very simple. All right, so that is done. If we take a look at Suricata, the actual Suricata service, so sudo system ctl status Suricata, it should be disabled. There we are. So it's currently disabled, which is good. So in order for us to test the configuration file, we can say sudo suricata. We use the T option to test it. And just like snort, we can specify the configuration file. So I can say sudo suricata t c. That's the configuration file. So suricata and suricata.yaml. And we can use the verbose output option there. So it's running it in test mode. And it's going to give you an overview of your resources and the actual fast output device, or the logging configuration is in fast mode, similar to what we did with snort. And it also has the Eve log output device, which outputs it in JSON. So you can see this is the name of this file here is called fast.log. So that's where you can find all the intrusion logs. You then have eve.json, which contains the same information just in JSON format. And you can see that one rule file was processed, 25,504 rules successfully loaded, and 0 rules failed. Okay, so that is done. We know that Suricata will run without any issues, right? So in order to start it, we can essentially just say sudo systemctl. We don't need to run it from the command line, or you can, but you can run it in. You can actually run it in the daemon mode, or run the Suricata daemon, similar to what we had with Splunk, which I didn't cover. Sorry, not with Splunk, with Snort. Which I did not cover. We had the daemon option, which will run it in the background. So there we are, run as daemon. So you can also do that with snort. That is something that I completely went over, but yeah, you can actually see that you can specify your own signature rules there and the actual configuration file. But to run it with systemd, you can simply say sudo systemctl start suricata .service. All right, so we can then check the status just to make sure everything is running as it should be. Should say active and loaded. Fantastic. So now that that is done, what that means is that it's actually running in the background. So that means it's actually monitoring the network traffic and is logging all files to the following directory. So var log and suricata. So you can see we have the fast.log file, which contains the actual intrusion logs stored in the standard output format, and then eve.json, which saves it in JSON format. So to run a quick test, we can utilize one of the Suricata rules that is included within the rules file, the default one, which is stored under the directory that we just saw. So it's going to be stored under this file. So if I list out the contents of this directory, that rule is part of this rules file. And that rule essentially just detects, whether we're querying. You'll actually see the actual event. It's much better if I do it that way. So to essentially test this out, we can say the following. So I can say curl http test my NIDS, which is used to test your network intrusion detection system. So test my nids.org. And we're just testing whether it's going to monitor or track all of this. And I know I'm running this from the actual server here. So I can say test my nids.org, uid index.html. Let me just type that in correctly, HTML, hit enter. There we are. So it just tells us UID root. So that information is considered to be is actually considered to be malicious, because it means that we have gained access to root, or an intruder could have gained access to root. So how do we know whether this was logged? Well, to do that, we can say sudo cat var log, and we can go under suricata and fast.log. And you can see that that was actually logged there. And it's, as I said, it's running in the background, which is absolutely fantastic. So as you can see here, we have the actual log here. So it tells us where it was coming from, where it was going to, etc. Right? So this is good that it's working. We know that it is indeed working. So let's talk about custom rules. All right. So in order to do that, I'm just going to stop the Suricata service because we don't need it running right now. So I'm going to say stop. And let's take a look at how to write custom rules. So I'm going to store the rules. We can store it. You can store them wherever you want. Just make sure to update that in the actual suricata.yaml config file. So I'll say sudo vim etc. We can store it here or under the var lib directory under suricata and rules. So I can say etc suricata rules, and I'll say local.rules. So I'm creating the rules file here. And just like we did with Snort, the actual syntax is exactly the same. So we say alert, the type is of alert, and then we can say ICMP. In this case, this is going to track or log any pings that are coming from any external network into our home network. So we specify the home net variable. So that means the subnet that we specified. And we can then specify the message that we want displayed in the log. So we can say ICMP ping. And let's see, I believe that is the correct syntax. And then, yeah, we can just close that up there. And we can then specify the SID, which in this case, we'll just keep it to 1 because this is a custom one anyway. Revision 1 as well. And we can then close those brackets there. Okay, so I think that looks good. We didn't specify the port here, which is why the syntax highlighting was not reflected. So any port coming into our home network. So write in quit, and then we can modify the YAML configuration file. So let me just head over to that command there. I should have actually typed it in, but there we are. So we are looking for a rule path, and we want to add it here. These are the other rules or rule sets that we would like to add. So I'll say this is under etc suricata rules local.rules. Let me type that in correctly. So local.rules, and we can write in quit. You can then test the configuration just to make sure there isn't any issue with it. So I'll hit enter. And if all is good, then we know that we can run Suricata without any issues. And then we can test whether, that ping is actually processed or, detected by our intrusion detection system. So we'll just give this a couple of seconds. All right, so now that is done, we can say sudo systemctl start suricata.service. Okay, that is done. I'm just going to run a ping from the Kali Linux system, so I don't need to show you that. I'll just run a ping on this device, or I can run it on maybe the router, on my router here. So I'm just running the ping now, and I'll let it run for a couple of seconds, and we'll check the log to see whether that is actually detected. All right, so I've performed the ping, and we can take a look at the log file now. So let's take a look at the fast.log file. In this case, it doesn't look like, is that actually started? Is the Suricata service started? So I'm going to say status. There we are. And if I type in ifconfig, that is correct. So sudo systemctl status var, that actually should be logged. I'm just going to run the ping again. All right, so after a couple of seconds, I just ran the ping on the actual Ubuntu server, primarily because I know that I'd blocked pings on my router, which makes a lot of sense now. But you can actually see that based on our custom rule ICMP ping there, you can see that, we didn't set the priority, but we could have, just as we did with Snort. So it's ICMP, where it came from. So it came from this system here, and it came onto the Ubuntu server. So those have been logged, and, we can essentially keep up to date with the latest logs. Now, I also wanted to showcase the actual JSON or the eve.json log file, which, again, if you actually cat out the content with cat, it's not going to be readable because it's in JSON format. So one tool that we can use is the JSON command line processing tool, also known as JQ. So we can say sudo apt get install JQ. It's a very small package, and it will essentially allow us to view this in a way that makes sense. So we can utilize the tail utility to display the latest logs or alerts, if you will. So the file is var log and suricata eve.json, and we can then pipe that into the JQ utility and say that we want to select and within brackets, we can say .event. So the event type is going to be equal to an alert. So we'll put this in double quotes. The syntax is fairly simple, and we then need to close the brackets and single quote there, hit enter, and because this is using tail, then we would need to perform we need to perform or simulate another type of intrusion. In this case, we can just perform a ping, and I know that that should be displayed because Suricata is running in the background. So let me just perform the ping here, and because we're using tail, it's going to display the latest logs. So we'll give this a couple of seconds. All right, so after a couple of seconds, I just performed the ping on another device on my network. You can see that this is really helpful when you have this data displayed in JSON format, because you essentially get information like the timestamp, the source IP, the source port, the destination IP, the destination port, the protocol is ICMP, and then of course we have the signature, which is ICMP ping. Action is allowed. If you were running it in IPS mode, then we could say, drop or reject, etc. But yeah, this is very useful. As I said, this can be very useful when you're importing it into tools like Zeek, or when you're performing event correlation. So yeah, we can just terminate that command there. All right, so we've been able to take a look at the logs and the log format. What we now need to take a look at is, because I think that's pretty much it in regards to what we needed to do, we actually need to configure Suricata and Wazuh, right? So I already have set up a Wazuh server just for this demonstration. This is not the one we used in the previous video, so I'll need to add this system as an agent. So I'll just log in for the first time so you can see what that looks like. So again, Elastic Stack here. And we'll give this a couple of seconds. And this should be running without any issues. I'm just going to let it query all the, run all the checks it needs to perform. Looks like we have an issue here. Yeah, it looks like it's okay now. So let's just restart that. Let's perform the health check again. Okay, that looks like it's done checking correctly. What we can do next is we can go ahead and make a few configurations that we need to perform. Ideally, in this case, we do not really need to perform or enable vulnerability detection. So I'm going to add an agent here. And before we do that, I think we need to configure an option under the configuration here. So if we take a look at the configuration, we can see that JSON output, yes, that's for OS sec. The logging format, that's fine. Policy monitoring, that's fine as well. What's the other option that we needed to? We don't need OS query here. Vulnerability detector is actually disabled. We don't need that right now. Let's see, file integrity is enabled. That's perfectly fine. And I'm going to add this Ubuntu system. So I'll say Debian, this is x86. We need the IP address of the Wazuh server here. If you have a domain, that will be applied. We'll just add it to the default group, and I can copy this command, and that should install it. So what we'll do is, yeah, let's just hit enter. That's going to download the Debian package and install it. There we are, unpacking the Wazuh agent, and it's going to set it up with the correct parameters. And then systemctl daemon reload, and we can essentially enable and start the Wazuh agent. So I'll say sudo systemctl stop Suricata first, because we don't need that running right now. Sudo systemctl daemon reload, sudo systemctl. If you want the Wazuh agent to run on system startup, we can say enable Wazuh. Let me just type that in correctly. So Wazuh, what's the name? It's the Wazuh-agent. There we go. and we can then start it. And then we need to make, it looks like we had an issue here. So let's just check the status here, because for some reason, status, it looks like we have an issue with the configuration. That's not being displayed here. Wazuh log collector, invalid value element for log collector. Let's see if we can modify the configuration. So we can say OSSEC or OSSEC etc. I believe it should be under that directory, and the name of the file is ossec.conf. I believe we need to configure a few things. So sudo vim. All right, so that looks like it's fine. What we need to configure in terms of log collection, which I think was what was causing the issue. System inventory, sys collector disabled, no. Startup, yes. Packages, ports, that's fine. Let's see. Synchronization is fine. SCA is enabled. File integrity is enabled. Let's see what else we have here. Database synchronization. Local. So this is where we can specify our own logs. So the actual log files. So this is the log file that is correct. That is actually collected. So that's the netstat command. Active response. It looks like we don't have anything there. Okay, so we can add our own log format. So this is for active response. This is snort syslog local file. We need to add the actual. We need to add another local file option here. So I'm going to say local file. I'm just going to add in the lines and then I'll show you what I've added. All right, so this is the configuration here that will allow us to, or will allow the agent to send back the logs within var log suricata eve.json, because we want them in JSON format. So I'll just write and quit, and let's see if we can actually start that Wazuh agent. It looks like we still have the issue here, so I'm just going to zoom out a little bit. And if I say status, let's see what the issue is. Invalid element for log format, which is snort. And then we have another configuration error. So configuration error at etc ossec.conf. Another one on the following line. So 1202. All right, so I managed to fix the issue. This was to do with the actual snort log location, which was what was causing the issue. So I managed to remove that line from the configuration file, the ossec configuration file. So all I did was at the bottom here, where you can essentially specify the log files that you would like Wazuh to essentially import or to essentially display. I got rid of the snort, the actual snort configuration here. So we have syslog, we have the active response log, we have auth.log, syslog, dpkg.log, kernel.log, and eve.json logs. So I can write and quit, and we can then say sudo systemctl start suricata, suricata.service. So now the intrusion detection system or suricata is running in the background, and it's going to detect any suspicious network activity. All right, so once that is done, if we go back to Wazuh here and we click on agents, that agent should communicate back. There we are. You can see it there. And if we take a look at security events, and this is where we can then click on the actual events themselves, and then we can filter based on what we are looking for specifically. So the index is Wazuh alerts. We then have the ability to essentially, bring in the eve.json files produced by produced by Suricata. One additional configuration that you need to make in order for this to work, as I've seen with my own experience, is to also add the actual, Suricata log file here, the actual specification within the Wazuh configuration. So I'm just going to save that there, and we're going to restart the manager now. So I'll just click on that there, and we'll give that a couple of seconds. So I'm just going to wait for this to restart, and then once that is done, it should get those events or alerts that are being logged by Suricata. So after a couple of seconds, you will be able to essentially view the Suricata alerts, and you can view that by, again, clicking on the agent itself. So in my case, black box security events, clicking on events, and we can add the filter here, and the filter that we want to add is going to be called rule.groups, because we only want to view the Suricata log. So we're going to say rule.groups is, and we should have the Suricata option here because it should actually be displayed. So Suricata, for some reason that isn't being displayed. That's very weird. Although that is highlighted here. As you can see, we have the latest Suricata log. So as you can see, ICMP ping, that was the rule that we essentially generated. That's very weird that it isn't actually here. That's interesting. So let me just refresh this, because I think that's one of the issues here with the filter, but it should actually allow you to specify the rule group as Suricata. If not, you can still view those events. So you can see we have the Suricata alerts here. So yeah, it's actually added now. Fantastic. So we can head back over into events and add the filter there. Just wait for this to bring that up here. So we can say rule.group is, and we can then say Suricata. It should actually exist here. That's very weird that it doesn't. So rule.groups is, let's see. I know we need to specify the group. So rule.description, GID, rule.description is, let's see, there aren't any options here. So we can say in this case, hold on. So let's actually use the previous filter. So rule.groups is, and you know, we can then say that actually should exist here, but for some reason that's not being displayed. As I said, it should actually be highlighted there. We can say exists, and in this case, you know, we can say let's just say it is there, but that, as I said, that's not being highlighted there. If I show the syslog events, because we're using syslog to get those ones there, you can see it doesn't display that there, and that is because we should be able to specify the actual filter. So, you know, let me just say rule.groups is, again, that should be highlighted, although I think that might be an issue with the actual Wazuh manager. So if I restarted it, you would be able to see that. But if you click on security events here, you can see that that actually is highlighted. So we have Suricata being displayed here in terms of the alert groups. Well, should we actually use alert groups? I'm not really sure. So we can say maybe alert.group. Alert, no, that's not. So we can say alert. Yeah, that's I don't think that'll actually tell us that there, because alert GID, if we say is and we select that there, yeah, so that's not going to work. So if I say rules.group, rule.groups is equal to, in this case, yeah, it's still not highlighted. So let me just restart Suricata. If it doesn't work, it doesn't work, but you can see that the Suricata alerts are being logged here, which is great. So, you know, they're also being highlighted here under the rule groups, which is very weird. So let me just restart that. So management, configuration, and I think we can actually restart the manager there. So just restart that. Just wait for it to restart. So I've just restarted the manager, and I think we can just say Suricata here just to have it displayed. So if I hit save, then, because that's not an added rule group, you can see that's actually being displayed now. So we click on events. Even though Suricata is not coming up as a rule group, we can actually get those alerts or events being displayed here by adding the rule group. So we can just say, let me just click this here, include in results, and I click on it again, edit this filter. You can see rule groups is, and then just type in Suricata, and that should work. So we can just test one more time I'm just going to run the same one of the same tests that we performed earlier on, whereby we essentially made a curl request to the actual to a website called testmynids.org, where we're essentially just checking the user ID or getting a user ID response back. So I'll just open this up, and I can say, for example, curl, and we can then say http testmynids.org and uid index.html. And let's see if this actually works. So I'll just hit enter, and let's see whether that is actually logged here. So we can refresh that. And I know it usually takes a couple of seconds for Suricata to also to actually have that logged, and then it should actually be highlighted here. So I'm just going to give it a couple of seconds. There we are. We can actually see it here. Suricata alert, GPL attack response. And the great thing, because we used JSON, we have the table information there. We have the JSON tab there. You can see that we actually get the JSON data here. So we can essentially view information regarding that particular alert in this case. So yeah, that's really what I wanted to highlight in regards to Suricata. It's a really, really powerful IDS, IPS solution. So that's going to conclude the practical demonstration side of this video. So thank you very much. If you have any questions, please leave them in the comment section, or you can join the Hackersploit forum and I can give you a response there. The link to that is in the description section. If you want to register for part 2 of this series, which will be on Linode's On24 platform for free, you can do that by clicking on the link in the description section as well. With that being said, in the next video, we're going to be taking a look at security event monitoring with Splunk. So essentially what we'll be doing is taking a look at how to set up Splunk through Linode, which is really awesome, and then how we can get the same logs, the various snort logs and the Suricata logs into Splunk for monitoring. It's essentially just going to be the similar process with as we just saw with Wazuh. The only difference is we're going to take a look at how we can use Splunk for security event monitoring, and how to essentially have those logs get sent to Splunk so that they're actually displayed in real time. So that's going to be it for this video, and I will be seeing you in the next video.